दोन
नाही इथे नाही आहे. ऑडियन्समध्ये माईक्स फिरवत होता. हा तो सुवास सुहास सुहास दुसरा माहिती आहे का? चला इकडे 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 जागा इकडे मॅडम इकडे मॅडम कुठे कुठे
नमस्कार. राष्ट्रीय विज्ञान दिनी आपण इथे आलात आयुकामध्ये त्याबद्दल आमचे धन्यवाद आणि आभार. हा जो आजचा कार्यक्रम आहे तो आता आपण आस्क सायंटिस्ट म्हणून जो कार्यक्रम आपण दरवर्षी घेतो तो आता आपण चालू करू. या इथे माझ्याबरोबर स्टेजवरती जरा 4 डिग्निटरीज हिअर जे तुमचे प्रश्न जे आहेत ते त्यांची उत्तरं देणार आहेत. फर्स्ट ऑफ ऑल द करंट डिरेक्टर ऑफ IUCAA प्रोफेसर श्री आनंद, the former director of IUCAA, Professor Ajit Kembhavi, then the current faculty member here at IUCAA, Professor Rajeshwari Datta, and then we also have a postdoctoral scholar here from IUCAA, Sneha Pandit, Dr. Sneha Pandit. So, दरवर्षीसारखी आपण खूप सारे प्रश्न आम्हाला इथे विचारले, जे सगळे काही माझ्याकडे आहेत. आम्ही त्यांच्या थ्रू गेलो आणि बघितले की कुठले कुठले प्रश्न आम्ही आत्ता इथे उत्तर देऊ शकतो आणि सगळ्या जणांना त्याचा फायदा होईल. आणि मग त्याच्यावरनं आम्ही हे प्रश्न ठरवलेले आहेत आणि आता ते आपण घेऊ. काही प्रश्न मराठीतनं होते, काही प्रश्न इंग्रजीतनं होते. तर वी विल डू अ कॉम्बिनेशन इंग्लिश मराठी असं नेहमीसारखं. ओके ठीक आहे. Okay, so let's start with the first question. So this is about, someone is asking, how does the rainbow form? Okay, so you must have seen rainbows in the sky, especially during the rainy season. You see that there are beautiful colors and it's a semicircle. So we would like to understand, this person who asked the question, we would like to understand how does the rainbow form? Why does it split into colors? Okay. So if one of you would like to take it.
Good afternoon. So if you look at sun's light, it looks more or less yellow. Okay? But what we know is that any light you see is a combination of several colors. Okay? Whenever the light goes through any medium, you have seen now, if you go in the street, if there is an oil spill in the road, and you will see colors there. Okay? The color is coming from oil or coming from the sun. Because the same oil, if you see in the evening, you will not see the colors at all. So basically what happens with the rainbow is that when light goes through these water droplets, it gets split into different colors, and when it comes out of the droplet, all colors are seen distinctly. Like the way you see similar kind of reason why we see colors in the oil spill. Okay? So this is like, this is a simple explanation.
So one of the things that I always get confused by is when I look at the rainbow, I never see the rainbow around the sun. It is always in some different place. So could you please explain why?
That basically explains, if rainbow is produced on its own, and if sun is nothing to do with the rainbow, you will see in any direction. Okay? So basically what happens is that to get the rainbow, the light should come from somewhere. It has to get into the water, and it can just, if it just go through the water, you will never see any light, right? Because it's going to the other side. Usually what happens is that the light enters into the water and that gets reflected. There is a phenomenon called total internal reflection. Because of this, it comes back. So usually what happens is light goes like this and comes back in the same direction. So if you want to get this kind of rainbow happening, so the direction of sun should be behind us, so that it can go like this and come back.
Yeah, so next time you observe a rainbow, make sure you also observe the sun, where it is exactly, and where the sun drop, where the raindrop is, which is actually causing a rainbow for you. So this raindrop is acting like a prism, okay? And then it's not only splitting the rays, but also pushing it back towards you, okay? So that's quite interesting that these kind of phenomena also happen, and how actually people figured out that this is indeed what is going on. Okay, okay, let's take another question. This is from Shrikaran Kaila Singer. This is in Marathi. Okay, सूर्याचे तापमान पृथ्वीवर कमी अधिक होताना जाणवते आपल्याला, परंतु प्रत्यक्षात सूर्याचे तापमान कमी जास्त होत असते का, हे त्याला विचारायचं.
सूर्य हा एक मोठा तारा आहे, त्यातून फार ऊर्जा बाहेर पडते, प्रचंड प्रमाणात ऊर्जा बाहेर पडते, आणि सूर्याचं तापमान कृष्ण बघावरती त्याचे आपलं जे दिसतं येलो कलर दिसतो किंवा रंग साधारण पण 5600 डिग्री इतका आहे असं आपण म्हणू शकतो. त्याला इफेक्टिव्ह टेम्परेचर म्हणतात. आता ते कधीच कमी जास्त होत, कारण का की आतमध्ये ऊर्जा बनते सूर्याच्या मध्यावरती, त्याचं हायड्रोजनचे हिलियममध्ये परिवर्तन होतं आणि मग ऊर्जा त्यातून निघते आणि ती पृष्ठभागावरून येऊन मग आपल्याकडपर्यंत पोहोचते. आता त्या ज्या प्रक्रिया आहेत त्या फार कॉन्स्टंट असतात, त्याच्यामध्ये काहीही फरक पडू शकत नाही. तर मग आपलं तापमान का बदलतं? आणि दुसरं म्हणजे आपली पृथ्वीचं जे ऑर्बिट आहे ती अशी गोलाकार नाही, ती थोडीशी निमुळते, अगदी थोडीशी. त्याच्यामुळे काही सीझनमध्ये पृथ्वी सूर्याच्या जवळ असते आणि काही थोडीशी दूर असते, पण त्याचा पण प्रभाव बरीच पडतो. हा जो तापमान कमी जास्त होतं ते आपल्या पृथ्वीच्या भोवती जे वलय आहे, ज्याला आपण ॲटमॉस्फिअरिकल वातावरण म्हणतो, त्यात जे बदल होत असतात आणि पृथ्वीचा ॲक्सिस असा टिल्टेड आहे, तर त्याच्यामुळे काय होतं की आपला जो समर असतो उन्हाळा एप्रिल मे जून जुलैमध्ये, त्याच्यावरती आपल्याला मॅक्सिमम प्रकाश मिळतो. त्याच्यामुळे इथं आपलं हवा जास्त तापते, त्याच्यामुळे आपल्याला तापमान वाढतं. मग आता डिसेंबर जानेवारी फेब्रुवारीमध्ये आपल्याकडे हिवाळा असतं, पण जर का तुम्ही साऊथ आफ्रिकेमध्ये गेला, चिलीमध्ये गेला, तर मग तिथं उन्हाळा असतो. तर बऱ्याच वेळा झालेलं आहे की आम्ही इथून साऊथ आफ्रिकेला जातो, इथं आयुकामध्ये लोक, आणि जाताना तुम्ही इथं हाशहूश करत गेलेलं असतं, शर्ट घालू का नको विचार करत. तिथे गेल्याबरोबर तुम्हाला मोठा कोट घालायचा, कारण तिथं थंडी असते. तर हे जे तापमानात फरक होतो, तर तो सूर्याच्या तापमानाच्या फरकात होत नाही, तर आपल्या पृथ्वीचं जे इन्क्लिनेशन आहे ते आणि दुसरं ॲटमॉस्फिअर आहे त्याच्यामुळे.
पण हे जे इन्क्लिनेशन बद्दल आहे ना, ते मला शाळेमध्ये मी पण ऐकलेलं होतं, पण मला हे कळायचंच नाही की पृथ्वी जर अवकाशामध्ये आहे तर हे जे कललेला अक्षय आहे तो नक्की कललेला आहे म्हणजे काय? मी म्हणजे माझी मान वाकडी केली की मला ते सरळ दिसेल, असं केलं की असं उभं दिसेल, तर मग नक्की कललेला म्हणजे काय? आपण त्याचा अर्थ काय असतो ते सांगू शकतो?
त्याचा फार चांगलं उदाहरण आहे. जर का पृथ्वी एकुलती एक असती, सूर्याभोवती फिरत नसती, तर मग तू कोणत्या बाजूला कललेलं आपल्याला सांगता आलं नसतं. कारण कललेलं जेव्हा आपण म्हणतो इट हॅज टू बी रिलेटिव्ह टू समथिंग. आता जर का मी इथं उभा राहिलो आणि समजा असं मी एका बाजूला कळलं, तर ते रिलेटिव्ह टू दीज वॉल्स असतात. जर का हे नसले तर मग समजा मी अवकाशात आहे एकटाच, तुम्ही असं आहे उलट आहे तर सोलट आहे तर कोणाला समजू शकणार नाही. पृथ्वीचं काय होतं की ते ऑर्बिट, आणि मग जर का कल्ली नाही तर त्या ऑर्बिटला नॉर्मल म्हणजे काय की सूर्याचा इफेक्ट तेवढा झाला असतो त्यावेळी कोणत्याही बाजूला. आता रिलेटिव्ह टू ऑर्बिट
हे जे झुकलेली आहे कललेली आहे ते ऑर्बिट ज्या प्लेनमध्ये करते त्याच्या त्याच दृष्टीने अजून एक प्रश्न होता आहे की हे जे क्रिकेट मॅचेस होतात त्या क्रिकेट मॅचेसमध्ये बऱ्याचदा आता डिसेंबरमध्ये जे बॉक्सिंग डे क्रिकेट वगैरे मॅचेस होतात ते नेहमी सदर्न हेमिस्फिअरमध्येच का होतात, म्हणजे ऑस्ट्रेलियामध्ये किंवा साऊथ आफ्रिकेमध्ये. हे जे दिसतं ते त्याचं कारण हेच आहे का?
हो,
की आपल्या इथे जेव्हा हिवाळा असतो तेव्हा तिथे,
कारण आता इंग्लंडमध्ये वगैरे थंडी फार असते. तुम्ही बघितलं असेल की फुटबॉल खेळू शकता, कारण फुटबॉल 1-1.5 तासाचा गेम होतं, तेव्हा पण त्रास होतो. पण क्रिकेटमध्ये 3 दिवस 5 दिवस 1 फुल दिवस आपल्याला खेळता येतं, सगळ्यांना निमोनिया होऊन घरी राहतो. तर त्याच्यामुळे तिथं दक्षिणेत जाऊन खेळावं. आपल्याकडे मात्र 365 दिवस क्रिकेट खेळता येतं, तो बघता ते होतं.
बरं, धन्यवाद. सो याच्या नंतरचा जो प्रश्न आहे, दिस इज इन इंग्लिश, सो मे बी राजेश्वरी यू कॅन आन्सर. व्हाय आर ऑल स्टार्स फिक्स्ड इन स्पेस? So when you look at the sun and stars in the night, you will see that there are constellations and their shapes and sizes, they will appear exactly the same, right? If you look at the north, then you will see the Big Dipper किंवा सप्तर्षी ज्याला आपण म्हणतो, त्याचा काही आकार एवढा चेंज होताना नाही दिसत. मग why are these stars just fixed in space? This is the question that this person.
Okay, so the question is why are stars fixed in space? I would change it a bit and say why stars appear fixed in space. So the key word to focus here is appear. Stars appear to be fixed on a sphere very far away from us, and it's because stars, like our closest star is sun, Do you know what's the after Sun? What is the closest star to Earth? It is Alpha Centauri, Proxima Centauri, a star system. Now that's very far away. That's about 4 light years away. Now all the other stars are even further away. So stars are so far away that they appear to be fixed on the sky. They actually do move. They have motions, but because they're so very far away from us, their motion on the Earth, we cannot see it with our human eyes usually. So we need more powerful instruments. That's why we have telescopes if you want to observe the motion of stars. So for a long time, in ancient days, the astronomers, they were not able to see with their own eyes motion. But for example, you can see the planets move over because they are relatively closer to us, right? So in the earlier days, people could map how the planets are moving. And by mapping how they are moving on the sky, they could make out, okay, they could get some idea about the solar system. But they also saw some objects. Okay, at that time there was not that much theory about what stars are and so on, but they saw that these objects are there, which are not moving, which are twinkling, which are so they thought that this, by inference, since compared to planets, they are not moving, so they must be even further away than the planets. But now we know that they are stars similar to our sun.
And then they move.
And they also
Right, yeah. Excellent. So then there's another question about this. So if you look at the sky, you observe the sun all the time. In fact, you get a lot of heat from the sun. And in the night, the sun disappears and all of us go to sleep. So one of the questions that is asked is, if the sun gets destroyed, okay, I don't know why and how, but if it gets destroyed, then what will happen to life on Earth? Ms. Neha, if you want to take this.
So, sun will not get destroyed. It is a star. It has its own trajectory of life. So currently, it is a young dwarf, as they say it. It will get into a middle-aged state, and as it ages, so current age of the sun is nearly 5 billion, 4.6 billion years. Usual age of this mass and radius star, sun-like star, is like assumed to be nearly 10 to 12 billion years. So after 8 or so billion years, when it ages and becomes a red giant, it will become huge. So all the energy in the core, which is maybe in the previous talks you guys saw, or in the sessions in the other side of IUCAA, there are several exhibits where you saw that the energy in the stars is produced by nuclear reactions, and then nucleons fuse. So when several nucleons fuse, they become bigger and bigger, and in that way there remains less and less nucleons after very long time of billions of years. So because the mass reduces, the mass converts to energy, energy is radiated away, then there is something called hydrostatic equilibrium. So the gravitation field keeps the mass together, and this energy produced will create the motions and create something like that kind of balances this gravity. But because the mass is reduced, this equilibrium is lost, and that's why the external envelopes or the atmospheres outside of the sun, they will evolve and they will go away. And in a way, because currently the size of the sun is smaller than how it will be 8 billion years after now, Earth is at a good distance, so then we get energy, we can sustain a life. Earth is in habitable zone. But when that red giant phase happens, the outer envelope will kind of engulf the Earth, even Mars. So yes, that will happen, but that is extremely far away in time. So probably we don't have to worry about that.
I don't have to worry. Neither do you. Even though I'm a little bit older, I suppose you are still okay. Okay. Okay, but then if instead of the sun blowing up and so on, if it just disappears, then what will happen on the Earth? Like, is there something that we can expect if the sun just disappears overnight and does not
This
stop?
is a thought question. Sun will not disappear, but if there is no energy, yeah.
This kind of question I can answer probably. See, sun does two things to us. One is because sun is there, we are going around the sun. If sun is not there, we will be going randomly wherever. Our earth will not be going round and round if sun is not there. That is first thing. And we are saying temperature is high in the daytime, less in the night. But we also know that if the temperature is very much different, trees and all are not going to be there. And in the same sequence, if it becomes too hot or too cold, we will not be there. So if you say sun is destroyed, there will be two effects at least I can think of. One is that we will no more be going around, because if sun is no more there, there is nothing to control our motion. Second thing is that we may not be there to realize that we are not going around. We will all be killed because of the temperature variations. So these are not going like what she explained. If you follow physics, this is not going to happen based on physics what we know, but it is good for us to ask these thought-provoking questions.
Yeah. Sometimes planets roam around. Maybe.
Yeah. And you do see roaming around or rogue planets which are not going around stars. So we may become a rogue planet in that sense, without any human beings.
Okay. Without any human beings. So we will not be around to see it maybe. But yes, of course.
See, while this is very hypothetical, म्हणजे आपण म्हटलं की आता ताऱ्याभोवती ग्रह आपला फिरतोय, मग सन नाहीसा झालं तर काय होणार, सूर्य नाहीसा झाला तर. पण आता अजून एक नॉन हायपोथेटिकल सिच्युएशन, की दोन तारे एकमेकांभोवती फिरत असले की त्याला बायनरी स्टार म्हणतात. आणि ते दोन तारे असं असतं की समजा एक तारा मोठा आहे आणि एक लहान आहे, म्हणजे त्याची घनता मास जास्ती आहे. ज्या ताऱ्याची मास जास्ती असते तर तो तारा एव्हॉल्व्ह होतो, आणि तो एव्हॉल्व्ह होऊन मग त्याचा स्फोट होतो. आता हे सांगितलं की स्फोट होईल. आता स्फोट झाला की त्या बायनरीचं डिस्ट्रप्शन होऊन जातं, राईट. आणि बायनरीचं डिस्ट्रप्शन नाही काय, कारण आणि सांगितलं तसं गुरुत्वाकर्षण कमी होतं आणि त्याच्यावर दुसरा तारा निघून येतो. पण काही तारे आपल्याला दिसतात की जिथं न्यूट्रॉन तारा किंवा ब्लॅक होल असतो त्याच्यावरती दुसरा तारा फिरत असतो. तर ते कसं शक्य, कारण एखादा स्फोट झाला न्यूट्रॉनचा तर तो म्हणजे बायनरीचं डिस्ट्रप्शन होणार. मग तुमच्यासारख्या विद्यार्थ्याने तो PhD करत होता ते 1955 साली त्यांनी त्याच्यावरती एक प्रमेय बांधले होते की काय होईल, म्हणजे मोठा तारा स्फोट व्हायच्या आधी त्यातून द्रव्य लहान ताऱ्यावरती जातं आणि मग तो लहान तारा मोठा होतो, मोठा तारा लहान होतो, मग त्याचा स्फोट होतो. त्याच्यावर काही प्रॉब्लेम होतो. इंटरेस्टिंग बऱ्याच साधा प्रश्न विचारलेला आहे, पण त्या साध्या प्रश्नातून कितीतरी गोष्टी बाहेर पडू शकतात.
अगदी. सो हे जे प्रश्न विचारणं आहे ते फारच महत्त्वाचं आहे, हे तुम्हाला लक्षात आलं असेल. आणि सकाळी प्राध्यापक नार्वेकर ते पण आलेले होते इथे आणि त्यांनी सांगितले की आता आम्ही तुम्हाला प्रश्न विचारणार. तर याच प्रकारची गोष्ट आम्हालाही करायची आता तुमच्याबरोबर. तर मी एक प्रश्न तुम्हाला विचारणार आहे, मे बी मराठीत विचारेन. मराठी सगळ्यांना कळते का? कोणाला कळत नाही? काही जणांना. ठीक आहे, मुख्यत्वे करून मराठी आय थिंक कळतं, तर मग मी मराठीमध्येच विचारतो. तर आपण जे काही रोज बघतो ना की सकाळी जेव्हा आपण उठतो तेव्हा सूर्य पूर्वेला उगवतो, मग तो पश्चिमेला मावळतो. त्याच्यानंतर रात्री जर तुम्ही तारे बघितले ते पण पूर्वेला येतात आणि मग पश्चिमेकडे मावळताना आपल्याला दिसतात. तर मग आपल्याला हे कसं काय माहिती आहे की पृथ्वी गोल फिरतीये, पृथ्वी स्वतःभोवती फिरतीये, ना की हे बाकीचे सगळे लोक म्हणजे तारे किंवा सूर्य किंवा चंद्र ते पृथ्वीच्या भोवती फिरतात? तुम्ही याचं उत्तर देऊ शकता का मला? जरा हात वरती करून दाखवा बरं, ज्याला उत्तर माहिती आहे तसं. म्हणजे असं नाही सांगायचं की मला पुस्तकामध्ये लिहिलेलं आहे की पृथ्वी गोल फिरते बाजू स्वतःच्या भोवती आणि त्याच्यामुळे मला हे सगळं फिरताना दिसतं. पण नाही, हात वरती करायचं आहे. ओके, यू हॅव टू रेज युअर हँड. आणि जे कोणी प्रश्नाचे उत्तरं देतील त्यांना आम्ही पुस्तकं पण भेट देणार आहोत.
It may be depending on the rotational force, gravitational force, first of all, and the second one is gravitational attraction.
ग्रॅव्हिटेशनल फोर्स तर सगळ्यांमध्ये तुमच्या आणि माझ्यामध्ये पण आहे. यू आर ऑल्सो अट्रॅक्टिंग मी, बट दॅट डज नॉट मीन आय एम रोटेटिंग अराउंड यू. सो एनी अदर? लेट्स सी. कॅन यू रेज युअर हँड्स? आय कॅन सी अ पर्सन स्मॉल साइज देयर.
लोक रॉकेट म्हणून बाहेर गेलेत म्हणून लोक रॉकेट मधून बाहेर गेलेत.
हो, लोक ऑर्बिट मधून बाहेर गेलेत आणि त्यांनी बघितलं असं तुला म्हणायचंय का? मे बी. पण लोक ऑर्बिटमध्ये बाहेर जाण्याच्या आधी पण त्यांना माहिती होतं. इनफॅक्ट जर तुम्ही आयुष्यातली काही प्रदर्शनं बघितली असतील आत्ता, तर त्याच्यामध्येही तुम्हाला उत्तर सापडलं असेल किंवा कोणीतरी सांगितलं असेल. इथे आहे, आपण एक उत्तर घेऊया आणि मग त्याच्यानंतर पुढे मूव करूया. बघूया अजून कोणाला उत्तर येतात का. दुसरा प्रश्न. Yes.
We experience day and night.
Huh?
We experience day and night.
Yes, we experience day and night. So if the sun is going around the earth, you will still experience day and night. Right?
नाही, but the सूर्य सोलर सिस्टमच्या मध्ये आहे आणि बाकीच्या प्लॅनेट्स त्याच्यावरती फिरत आहे.
नाही, हे तर पुस्तकातनं माहिती आहे ना.
नाही, सकाळी लेक्चर पण झालेलं.
सकाळी लेक्चर नाही, पण तेच लेक्चर म्हणता का तुम्ही असा कुठला प्रयोग आहे की ज्याच्याने कळतं की नक्कीच पृथ्वी गोल फिरते आणि सूर्य नाही आपल्या भोवती. एनी मोर? आपल्या इथेच आहेत काही प्रयोग जे दाखवलेले आहेत तुम्हाला आयुकामध्ये.
जो पेंडुलम आहे ना, बॉब ऑफ पेंडुलम,
हा,
तो पण दाखवतो.
कुठला पेंड्युलम? फुको पेंड्युलम. ओके, फुको पेंड्युलममुळे कसं काय कळतं सांगू शकते का? एकदा तुझं उत्तर बरोबर आहे, सगळ्यांना कळेल असं सांग प्लीज एकदा.
अर्थ रोटेट करते आणि आपण जे पेंडुलमचा पॉइंट घेतलेला आहे ना, तो युनिवर्स मधून घेतलेला आहे.
हे समजून घ्यायला लागेल, ठीक आहे. सो आय विल एनकरेज यू. फुको पेंड्युलम जो आहे तो जर तुम्ही बघितला तर त्याचं जे प्रतल आहे मूव्ह होण्याचं ते बदलत असते, आपल्याला बदलताना दिसते. जर पृथ्वी गोल फिरत नसती तर ते आपल्याला बदलताना दिसलं नसतं, ठीक आहे. तर हा जो एक्सपेरिमेंट आहे तो प्लीज जाऊन एकदा बघा. आयुकामध्ये त्याचं प्रात्यक्षिक जे आहे ते आहे आणि त्याच्यावरनं आपल्याला कळतं की खरंच पृथ्वी गोल फिरते ना, की बाकीचे सगळे गोष्टी आहेत की सूर्य आहे की जरी आपल्याला दिसतंय. Yeah, but that will still happen if everything is going around, right? So it is the Foucault pendulum which tells us. So you can give the books to this girl who at least listened and saw these experiments. And others can go around. Okay, thank you. Let's come back to questions that you had asked. Okay, so एक मराठीमधला प्रश्न आहे. जर का पृथ्वीमध्ये धूमकेतू येऊन पडला किंवा उल्कापात झाला तर काय होईल? सो हा जो प्रश्न आहे तो ना आत्ताच न्यूजमध्ये एक आलेलं होतं की एक मोठा ॲस्टेरॉइड आहे जो येऊन पृथ्वीवर धडकणार आहे, मे बी 7 वर्षांनी वगैरे. तर तुम्ही सांगू शकता का काय काय होईल असं जर झालं तर, आणि नक्की असं काही होणार आहे का?
जो धूमकेतू जेव्हा येतो तर धूमकेतूला शेपटी असते, हो की नाही? का असते ती? कारण की त्या धूमकेतू एक छोटासा दगड असतो जो अवकाशात फिरतोय आणि त्याच्या शेपटीमध्ये गॅसेस असतात. तर जर तशा प्रकारचा काही ऑब्जेक्ट पृथ्वीच्या जवळ आला तर असं पण होऊ शकतं, म्हणजे हे होणार नाही आहे, जस्ट अ थॉट एक्सपेरिमेंट. तो ऑब्जेक्ट जो आहे तो ते पृथ्वीभोवतीचं जे वातावरणाचा म्हणजे हवा आहे, वातावरणातला जो गॅस आहे तो त्याच्याबरोबर घेऊन जाऊ शकतो. आणि अशी थिअरी आहे की असं म्हणजे त्याच्याबद्दल ऑब्झर्वेशन्स आहेत, त्याच्याबद्दल लोकांनी संशोधन केलेलं आहे की व्हीनस जो शुक्र ग्रह आहे त्याच्या आजूबाजूचं जे ॲटमॉस्फिअर आहे त्याबद्दल असं कदाचित खूप आधी मिलियन्स ऑफ इयर्स अगो झालं असू शकतं. तर हे एक निष्पन्न आहे. जर तो ॲस्टेरॉइड खूप मोठा असेल आणि त्याची वेलॉसिटी खूप जास्त असेल तर तो पृथ्वीला येऊन दणकू पण शकतो, जसं जे मानलं जातं की डायनोसॉरच्या काळात झालं. तर अशा काही डेंजर गोष्टी होऊ शकतात. पण जर तो धूमकेतू छोटा असेल तर काहीच नाही होणार आणि मोस्टली तेच आहे.
ओके, सो बरेचसे जे धूमकेतू असतात किंवा उल्कापात जो होतो ते एकदम छोटे छोटे कण
खूप
असतात.
छोटे कण असतात आणि कारण ते खूप वेगाने येत असतात तर ॲटमॉस्फिअर मधल्या गॅस बरोबर ते आदळतात आणि तिथे कंबशन होतं, म्हणजे आग लागते आणि म्हणून ते आपल्याला चमकताना दिसतात जेव्हा ते पडत असतात. तर मोस्टली धूमकेतू किंवा उल्कांबरोबर म्हणजे हेच त्यांचं तिथेच त्यांचा शेवट होतो.
ओके, पण हा जो 2024 आत्ताच डिस्कवर झालेला जो ॲस्टेरॉइड आहे त्याच्याबद्दल काही म्हणजे मला काळजी करण्याची गरज आहे का?
काळजी करायची गरज नाही.
7 वर्षाचं मला पूर्णपणे प्लॅनिंग करून ठेवायला लागेल म्हणून.
एक आहे की ते वर्ष ते मुंबईवरतीच पडलं.
मुंबईवरतीच पडलं.
मुंबईवर पडलं म्हणजे लगेच तो धूमकेतू पडण्याच्या आधी स्टॉक मार्केट पडतो.
पूर्ण जग फिरून घ्यायला पाहिजे. पण काही शक्यता आहे का की हे खरंच होणार आहे की काही आपण करू शकतो त्याच्यासाठी? म्हणजे हा जर धूमकेतू आपल्या जवळ येणार असेल तर त्याच्यापासून वाचण्यासाठी आपण काही करू शकू का ते सांगू शकतात?
मे बी सायन्स फिक्शनचा आन्सर देऊ शकते मी. आपण ॲव्हेंजर्समध्ये वगैरे बऱ्याच सायन्स फिक्शन मूवीजमध्ये बघतो की त्या धूमकेतूला वरती म्हणजे रॉकेट सोडून त्यालाच जर छोट्या छोट्या दगडांमध्ये विभागलं तर मग तो म्हणजे नॅचरलीच ॲटमॉस्फिअरमधनं छोटे दगड येताना ते पोचत नाहीत जमिनीपर्यंत. तर ते सगळ्यात सोपं उत्तर असू शकेल. त्यासाठी म्हणजे इनफ टेक्नॉलॉजी आत्ता आपल्याकडे आहे. म्हणजे ह्या गोष्टी ॲक्च्युली मिलिटरीचा जो रिसर्च होतो त्याच्यात अशा प्रकारचे रॉकेट्स बनवले जातात की जे दुसऱ्या रॉकेटला मारतील की म्हणजे आपल्या लँडवरती त्याचा प्रॉब्लेम नाही होणार. तर तसेच रॉकेट्स आपल्याला त्या उल्का जवळ आली जर तर तिला मारण्यासाठी
आकाशामध्ये आपल्याला स्फोट करायला लागते ना. म्हणजे जी दिवाळी आहे ती त्याच दिवशी होईल मला वाटतं जर आपण त्याचा स्फोट केला तर. पण मला हेही कळालेलं होतं की तुम्ही त्याला म्हणजे पूर्णपणे स्फोट करायची गरज नाही. थोडंसं जरी त्याचा वेग कमी केला तरी काय होईल की तो जरी पृथ्वीच्या कक्षेमध्ये आला तरी पृथ्वी आधीच निघून जाईल आणि मग तो कक्षेच्या पासून निघून जाऊ शकेल. म्हणजे अगदी स्फोट करायची गरज नाही. कारण की खूप मोठा जर असेल तर तुम्ही विचार करू शकता म्हणजे पृथ्वीवरती जेव्हा आपण स्फोट करतो तेव्हा पृथ्वीचा स्फोट होत नाही ना. सो त्याच्यासाठी लागणारी जी ऊर्जा आहे ती पण खूप मोठा बॉम्ब असा लागेल. सो ते करण्याच्या ऐवजी थोडंसं जरी कमी केलं तरी इनफ होऊ शकतं. इंटरेस्टिंग. ओके, नेक्स्ट क्वेश्चन लेट्स टेक. So this is about watching stars and planets, right? When we look at the night sky, we can watch stars and planets with our telescopes also. So you will in the evening, if you stay in the evening at IUCAA, you will also get to watch the skies with some of these telescopes. So then the question is, why do we even launch telescopes to space? If we can use telescopes on Earth, why should we launch telescopes to space? Is this something that one of you can take?
Yes, so we can get a lot of information by looking through telescopes on ground, looking at stars, looking at planets and also other galaxies. But like Professor Srianand was saying, the light that you see from sun, for example, you know that it consists of different colors. So white light, if you pass it through a prism, you will get a rainbow, like a rainbow spectrum, Virgion, violet to red. So it has, which we call in astronomy, different colors to have different wavelengths. Okay, so so the part that we see using our eyes, we call it visible because we can see it using our eyes. So similarly, when you look through a telescope, you're seeing the visible or the optical light. Okay. But you must also know of some other types of light or electromagnetic radiation. For example, you know that everyone emits infrared radiation. You must have seen especially during COVID time, right? Those infrared guns used to measure
temperature.
temperature.
Yeah, I remember.
Yeah. Also X-rays, right? If you go to a hospital, sometimes you may have X-rays done. So these are radiations we cannot see using our eyes, but they are there. So they actually form a full spectrum of, it's called the electromagnetic spectrum, from very high energy, which you call as gamma rays, X-rays, then obviously visible optical spectrum, and then also radio waves. So radio waves you are again familiar with, which you use for communication. You must also know of the giant meter wave radio telescope. But so we get optical radio we can observe from the ground, but some of the radiation like X-ray, gamma ray, UV, some of these are actually very harmful for us. So like even bodies, celestial bodies, they also emit radiation all across the spectrum. So we also get X-ray, gamma ray, UV from these, which can tell us information about these celestial bodies. But if these radiation in the form of this gamma ray, X-ray, if they come through the atmosphere to the earth, they will be harmful for us, they will be harmful to life. And the very fact that life exists is because our atmosphere blocks all this harmful radiation. Okay, so it's good for us, because we survive, we don't get affected by the strong radiation. But we also miss out on information about these bodies which emit in different paths. So to observe in other paths, like other parts of the electromagnetic spectrum, like ultraviolet, X-ray, gamma ray, we need to go to space. So I think all of you have seen the model of AstroSat. You at least have heard of AstroSat. It's India's telescope, a satellite which consists of instruments that can observe the universe in ultraviolet, X-rays. There are also similar various other satellites. So that is one very useful use of sending satellites to space. The other effect is the Earth's atmosphere. It's very helpful for various things, but it also affects the light that we see on Earth in certain ways. So it makes pictures that we see of stars and other bodies slightly blurry. Okay, so it affects. So if we can go beyond atmosphere, we can bypass the atmosphere and get a more clear image of the objects that we study. So that's again another use of sending satellites to outer
space. So there are two uses. First of all, atmosphere, which is protecting us from these rays. We have to go and see those rays, then you have to go outside, right? Otherwise, when you have to choose between becoming an astronomer who cannot live, right, or going up. So it is easier to send things rather than not have an atmosphere. So yeah, it's good that we have this atmosphere which is protecting us, but then to see things in those wavelengths, you just have to go up. Okay. There's one more question which is related to this, which is related to how we see things in which we live. Okay. So, for example, we are living inside a big galaxy called the Milky Way. You would have heard about it. So there is a question which is asked, how did we exactly discover this Milky Way? How it is made up of? How can we make pictures of it? So is this something that someone can ask? Because I know that these distances are really large. I cannot travel with a camera and go above and take a picture. So the question is, how do astronomers know about the Milky Way itself?
Yeah, I think anything you see in the sky, it's difficult to see what kind of objects they are, because these are all projections. If you see a star, we don't know whether it is a very bright star which is close to us, or a very faint star which is far away from us. But in astrophysics, there are a lot of coincidences. There are certain things which happen, because of which we now know that we can reconstruct whatever we are seeing to some models. For example, if you all know, now if I have a sun and put planets around them, these planets will go around the sun, okay? This we know. For example, for some reason I don't show the sun, I just, sun is there, but I make it dark. It is not emitting any radiation. Till the stars will go around, okay? So what you can do now, if you show this to anybody, you see that I have 10 planets which are going around something. I don't know what it is. What will you conclude? You will say that there must be some star which is present there, and all these planets which are going around, since they are following some pattern, they belong to that star. You understand? You take sun, all planets are going around sun. Even if sun is not there, if you see planets going around some part, you will think that they form a system and they are going around something. There must be some object or something which is controlling motion of all these objects. Similarly, if you sit in Earth and you can look at nearby stars, you can look at gas which is present in our nearby regions, and just start looking at what they are doing. It's very interesting. The gas all, somebody asked whether everything is moving. In fact, everything in our universe moves. Either it moves away from us, or towards us, or around us. So what has happened is that in our galaxy, Milky Way, which we call Milky Way, you look at small region and start asking how these objects are moving, how the star is moving, how the gas is moving. Then you realize that they don't move just like anywhere else. They move nicely in a direction. So based on this motion, we can conclude that we are part of a galaxy. So this is hi-fi, right? We can do a simple exercise. I take you to space. In the night, I ask you to take a picture between Pune and Mumbai. right? You will find there will be a line filled with light going from here to Mumbai. You will conclude, what will be the conclusion? You are not coming to Earth. You don't know there is a road, you don't know there is a highway. But just looking at this, you must say this light is coming from cars. Cars are moving from one place to another. That's why there are huge crowd, traffic jams. And some places there is lot of light. What are these places? These are toll booths, because all cars are standing. So, to understand what is there in some place, it is not necessary that you have to go there and actually see. With little bit of whatever we understood, we can actually infer. Like the way you will say there is light between two cities, it must be the road. And similarly, when you come from abroad to Mumbai, you will clearly see, oh, okay, I can see Mumbai appearing from the patterns you see in the light. So the way we understood we are part of a galaxy is that we looked at the motion of stars. You have to monitor over a long time. It is not one day. You have to, each group of stars you have to monitor. You have to monitor gas. And not only that, you will also look at nearby galaxies. You have to see we cannot be very special, right? We have to assume that we are part of a grand plan. And look at around us and look far away from us, and then we reach a conclusion. Is that right?
So it's not easy, right, to do this, because you cannot take a picture, but then you can still map out. So it's amazing how many things you can do just by looking at nature and tabulating.
I think this is one thing.
Observations.
This is one thing all the young people should realize. What makes astronomy interesting is it is like your CID series in TV. Crime has happened. You know, log mar gaye udhar. Who killed it? How they kill it? What is the motivation behind killing? So you will go and look at evidences which were there. You will collect all of them together and build a story, right? This is exactly like this. Doing astronomy is exactly like criminal investigation. We just try to find out. But these are played under some rules. These rules are governed by mathematics and physics. So this is why it is not sufficient to just read book and understand. If you really want to discover something, you have to go and do mathematics and physics thoroughly. Otherwise, it will be very difficult to do what we are doing.
And so I just want to add to what Professor Srianand said. The first person to look at the Milky Way astronomically was Galileo, more than 400 years ago. So he got a telescope. It was a very small telescope. I actually seen that telescope. It's about 1 inch diameter. Okay, so then he did not invent the telescope. Other people had it, but they're basically looking at their neighbors and so on. So what Galileo did was that he pointed the telescope to different objects in the sky. And one of those was the Milky Way. Because nowadays you don't see the Milky Way, but when I was in school, I was in a small town and you could clearly see the Milky Way every night. And then he pointed the telescope to the Milky Way and then he resolved it into stars. Because you could see stars in the Milky Way. Okay, then it took a long time for people to realize it was not something which was far away, but the stars all over. You are seeing them only because as you go further and further, they become more crowded. And that is how this whole story started.
So it has a long history, and I think I should encourage you all to actually read about these questions too, and how it came about that we knew about this, the exact shape of the Milky Way. So now we will go to another audience question. Is it okay? Are you ready? Okay. You must have heard about this Aditya L1 satellite, right? Do you remember how many of you have heard about it? There are many exhibits there as well, right? Excellent. Okay, so I want to ask you a question regarding this, right? So Aditya L1, we know it also goes around the sun, right? Just like the Earth is going around the sun, Aditya L1 is also going around the sun. So we also know that Aditya L1 is closer to the sun, right? So my question is, how long does it take for Aditya L1 to go around the sun? Does it take 1 year? Does it take less than 1 year? Does it take more than 1 year? So let's see. Who wants to answer this question? Yeah, maybe there? Huh? So she thinks it's less than 1 year. Any more? Yes?
The Aditya L1 is not going around the sun exactly, it's orbiting the Lagrange point. So
but how long does it will go around the sun if you look carefully. The question is how long does it take? We can take one more answer only because now there are not many possibilities.
1 year.
I'm sorry?
1 year.
1 year. Why is it 1 year?
Because the sun has more density and has more gravitational pull.
So, so why 1
So
year?
it can pull it faster.
But then it is closer, right? So it should go then faster. Less than 1 year then, right?
No, but it's also very big at the same time.
See, now you can get more answers too. So the answer is correct that it should be 1 year, but the question is why? Why 1 year, right? It is closer to the sun. It's experiencing more gravitational force maybe because
It depends on speed. Speed.
Shall I tell you?
Yes, maybe it is
I'll
better.
give you a very simple reason why it takes exactly 1 year. Now it is at the first Lagrangian point, okay, which means L1. Right now L1 is between the Earth and the Sun. If the Sun and the Earth were static in space, then L1 would also be static. But the Earth goes around the Sun once a year by definition. Right, and therefore L1 is between the Sun and the Earth, so L1 also must be there. And then Aditya L1 is sitting at L1, so it also goes around the Moon.
So even though it is closer,
Yes.
it takes exactly 1 year still to go up.
And then it is like attaching a rigid rod. But Aditya L1 is not actually sitting at L1. It is in a very complex three-dimensional orbit around it. Small orbit.
Indeed, that you should have seen.
Just for kids who are watching football match or doing 100-meter race, you know that 100-meter race they finish within 10 seconds, 9 seconds, 9 point something. But when they run, have you seen? They will be in the middle of your TV set. So they will be running, but the position in the TV will be exactly same. Do you know why? Because the camera moves with the same speed as they move. In fact, if you are a YouTuber, you might have seen one funny video where the cameraman runs faster than the prize winner. You would have seen, na? This is what exactly happens. Aditya L1 and Earth, they are not, you see exactly as if they are not moving with respect to each other. This is like what you see in football, right? Or when you watch anything moving, right? Football match also, the person will be running with the ball with high speed, but he will be always in the center of the frame. That is because your camera is moving with high speed, same speed. Okay? That's what happened here, like what Ajit explained. If you want to, they may be looking at each other and keeping pace. To keep this, both should move with the same speed. Okay, that is the analogy. So imagine whenever we discuss, your footballer is in the middle of your frame. He is not moving. In the olden days, you will find this is moving. Nowadays, the technology is so good, they are frozen. It's the...
Yeah, indeed. So Aditya L1, even being closer, it will still take because it is right in between the Earth and the Sun. Okay. Okay. So let's go to another question. So this is about the solar system.
Sir, I have a
Someone has
question.
heard. Sorry. Yes.
Sir, why Aditya only L1? Why not L2, L3, L4?
Okay. Good. Maybe you want to take this. Why is Aditya only at L1 and not at other?
No, if you want to see sun, there are L1, L2, L3, L4. There are 4 points are there. If you want to see sun continuously, 24 hours, and all throughout the day, you have to be in L1. But if you don't want to see sun, okay? If you want to see outside, because if sun is not there, everything will be dark. You can look at the whole universe. You heard about JWST, James Webb Telescope, that is in L2, because it doesn't want to be affected by sun. So it is in the other direction. So you can go to L1, L2, L3, L4, whatever you want, L5 also. But usually better to go to one of them, L1 or L2, depending upon what you want. If you want to study sun, you go to L1. If you want to study universe, you go to L2.
Okay, good. Let's stop directly taking questions. So maybe the next question is about an interesting phenomena. So in the news, there was recently a lot of uproar about all the planets coming in a line. Right? Have you heard about this? 25th of January, I heard that all the planets were going to be in a line. So what is exactly this? What do we mean by planets getting aligned and being in one line? Maybe I have stumped all the scientists too. We are asking us. Let's ask the scientist.
No. Actually, what happens is that planets, all of them go around. They all go with some speed around the sun set by the what you call Kepler's law. But it is just if you want to see, we are in between, right? If you want, so if you are looking towards one direction, if you want to see all planets, they all should be in this direction, because planets which are away from us can be either behind or in front. Okay, because they are going around, either they can be behind or front. In a normal circumstances, it is random. Either some of them will be in front, some of them will be behind. In some special circumstances, you will see all of them in front of us. Only are behind us when the sun is not there, depending upon, I'm just giving an analogy. So you are going around all these things. If I ask all of them to go, only when all of people who are going around us are here, we will be able to see most of them. If some of them are behind, we are not going to see anything. So it can be predicted. That is why it is special, because since we know the motion of each planet, we can predict when this can happen. And precisely, you can also say whether they will be seen in a line or not. More than that, there is no great physical reason for that. It is just a chance coincidence which can be predicted if you know proper, whatever you call, gravitational physics.
Right? Yeah. Okay, so there is nothing special about it, and there is nothing special definitely about the day that was all over in the news.
When it happens, something special will not happen, or something bad will not happen. There is nothing to do with any of these things. It's just
so something to remember. Whenever there is a lot of hype that is made on the internet or television, just try to figure out why these things are happening.
Just for this, there is an important point. I am able to reach you because of sound is reaching you, right? If I want to touch a person who is sitting there, if I just do like this, I cannot do. You understand? So if I want to influence you, I have to communicate with you physically. So what I want to say is that whatever happens in sky will not influence our life whichever way you want. This is the important lesson, so don't worry about this is a bad day, good day, some great things will happen, some bad things will happen. Impossible. I can't reach people there, and physics, whether I am doing or somebody sitting in some other planet is doing, they are all same. So the thing you have to carry is that astrophysically, at these distances, we can't influence each other. Okay? So these are all coincidences, and it is beautiful that we understand physics, we can predict it. We have to congratulate us that our evolution is such that we can predict everything. That is what we have to be proud of, instead of being fearful about why it is happening and all. So that's not our question.
Yeah. Okay, excellent. So then there is another interesting question. So this is by someone who is a little bit elder. They are asking, why are all the laws of physics the same in the entire universe? So this, who wants to take?
Okay, this is my research topic, I can tell you. So I don't know, none of us know that whether law of physics is same everywhere. So as an open scientist, as an open-minded scientist, I am open to the fact that physics can vary from place to place. But then comes the question, what do you mean by physics? If you say physics is that if a planet is going around sun, I know physics at some level. It's called Newtonian kind of mechanics. Can it be varied everywhere? We can prove that it is more or less at that scale it is okay. But there are a lot of things which are not tested. So I think I spent 10 years trying to see whether physics in different part of the universe is different compared to what we are. So the question is interesting. We believe it should be same because our cosmology, whether it is built by whole world or built by Professor Narlikar, all depend on the fact that physics should not change with time and space. But following the scientific spirit, we should be open to, we have no proof to say that all physics as I understand is exactly there at a precision we would like to achieve, right? That's what is the answer.
Yeah. Do you want to add something to this? Or? No, okay. Okay, so, I mean, it's a hypothesis, but if some of you goes out and observes something, and you find out that some things are not matching, then it is something to think about. Right? It may not exactly be the same. Okay, so then maybe in the interest of time, we will take one last question. And this question is about how to estimate how many stars are there in the universe. Yeah, please.
So the question is, how many stars are there in the universe? Now, most of the stars in the universe are aggregated into galaxies. There are small galaxies and large galaxies. Our galaxy, the Milky Way, about which we already talked, is a completely normal galaxy. And it has got about 10 raised to 11 stars. 10 raised to 11 meaning how much? It is 1 billion is 10 raised to 9. Okay, which is 100 crores. 1 billion is 10 to the 9. So 10 raised to 11 is 100 billion stars. It has got. There are smaller galaxies, bigger galaxies, but let's not worry about it because ours is normal galaxy. Now, how many galaxies are there in the universe? So if I look at the universe with the biggest telescope I have now, then I count the number of galaxies. I mean, I can't count all the galaxies. I count galaxies in a small part of the universe and use that to estimate galaxies in the whole universe. That number also turns out to be about 10 to the 10 or 10 to the 11. Let's call 10 to the 11. And then, how many stars are there? 10 to the 11 galaxies into 10 raised to 11 stars. So it is 10 raised to 22 stars. More interestingly, every star is, we are quite sure that every star has more than one planet. So there are 10 raised to 22 planets. So imagine how many civilizations like us there could be. Now the question is, if I build a bigger telescope, a bigger and bigger telescope, am I going to see more galaxies? That is really not true. That is because you see that in order to have more and more galaxies, I have to go further and further away. So light from more distant galaxies takes more time to reach us. So conversely, the galaxies that we are seeing in greater and greater distance are younger. And in fact, now we have already reached distances with the James Webb telescope, where you are seeing galaxies in formation, right? Because we are seeing a young universe. So even if you build a very big telescope, you can't see beyond it. Maybe because the current age of the universe is about 11.8 billion years, 13.8 billion years. So maybe after 5 billion years, 18 billion years. So that is a different ball game, but not now. We have seen everything that we are going to see.
Okay, excellent. So with that question, maybe what we'll do is we'll do one more audience question and then after that end this session. Okay? So the audience question is the following. In astronomy, a lot of things you have to do. Right? Sometimes you have to imagine that you are somewhere else and then watching from there. Right? So you must have heard about these seasons or phases of the moon. In the textbooks that are given, they always put you somewhere in the space and show how things look like. Right? So this is a very common thing in astronomy. So now what I'm going to do is, I'm going to put you at a place where you have not been. Okay? So let's suppose that you are on the moon. Okay? Some people have gone to the moon, of course. You are on the moon and now you are observing the earth. What do you think you will see? Okay? So let's go one by one. And everyone who at least tries to give me some part of it, maybe we can provide them something. Yes.
Earth revolves around the moon.
He thinks that you will see the earth going around the moon. Is that right? Okay, maybe others can help. Yeah, there is one person there, maybe. Yeah. What do you think you will see? Yeah.
We will see Earth grow smaller and revolving around the sun. And seasons for me.
Seasons for the moon.
From the moon.
From the moon. We are talking about Earth. What will you see on the Earth? Right? When you are looking at the Earth, what will you see?
We will see it too smaller.
Yeah, of course, it will be smaller. Yeah, but that's the simplest thing, no? Where will it rise? Where will it set?
We will see that it will. We will see that it's day and night formation.
day and night formation of the Earth.
Each
Okay.
side is facing to the sun and its side is not facing to the sun.
Okay, perfect. That is good, right? So sometimes you will see Earth, sometimes some part of it will be lit and some part will not be lit. Okay, anything else?
हा सर
Yes?
चंद्रावरून असा ग्रह दिसेल की तो एकदम निळा दिसेल आणि कोणत्याही देशाच्या सीमा तिथे दिसणार नाही.
I'm sorry?
कोणत्याही देशाच्या सीमा तिथे दिसणार नाही, फक्त एक निसर्गरम्य पाण्याने भरलेला असा ग्रह आपल्याला
Okay.
दिसेल.
Yes, but will it move around in the sky is what I'm asking.
Maybe if you ask the question differently.
Yeah.
मी तुम्हाला
Okay,
असा
let's see.
हा प्रश्न असा विचारतो की आता आपण बघतो की चंद्राचा रोज अस्त होतो आणि उदय होतो आणि एक महिन्यात एकदा त्याचा आकार पण बदलतो, कधी तो पूर्ण नाहीसा होतो, कधी मोठा होतो. तर का आपण पृथ्वीकडे बघितलं चंद्रावरती बसून तर पृथ्वी पण आपल्याला अशी गोल जाताना दिसेल का, की आधी का एकाच जागी स्थिर दिसेल?
Yeah?
जसं आपण पृथ्वीवर बसून सूर्य उगवला, सूर्य मावळला म्हणतो, चंद्रग्रहण म्हणतो, सूर्यग्रहण म्हणतो. चंद्रावर गेल्यानंतर आपल्याला पृथ्वी उगवली, पृथ्वी मावळली दिसेल आणि पृथ्वीचं एक ग्रहण दिसायला लागेल.
Okay. So he thinks
So his answer is that you can see the earth, from the moon you can see the earth going round.
Yeah. But it turns out that that's not the case, okay? So now someone has to tell me why that is not the case. Right?
And what happens?
And what happens, right? Yeah?
Hi,
So actually चंद्रावरनं जर पृथ्वीला बघितलं तर पृथ्वी जी आहे ती अशी उगवताना आणि मावळताना आपल्याला दिसणारच नाही.
चंद्र पृथ्वीच्या कला दिसतील, चंद्राच्या कला दिसतात. चंद्र आपल्याला पौर्णिमेपासून अमावस्येपर्यंत लहान लहान होताना दिसतो आणि अमावस्येनंतर पौर्णिमेपर्यंत मोठा होताना तसंच पृथ्वीचंही दिसतं.
So पृथ्वीच्या कला दिसतील पण ती एकाच जागी का
स्थिर असेल.
उगवणार आणि मावळणार का नाही ते विचारायचं.
हा, त्याचं कारण असं आहे की पृथ्वी आणि चंद्र, चंद्राची एकच बाजू कॉन्स्टंट पृथ्वीच्या दिशेने आहे, त्यामुळे चंद्राहून जी पृथ्वी दिसणार आहे ती तशीच कॉन्स्टंट दिसते.
ओके, दॅट्स द राईट आन्सर. ओके, सो ही जी गोष्ट आहे त्याच्यासाठी तुम्हाला कुठेतरी दुसरीकडे जायला लागतं आणि तिथून बघायला लागतं, विचार करायला लागतं की आपल्याला काय दिसतंय ते. सो पहिली गोष्ट हे लक्षात ठेवायला पाहिजे की पृथ्वीवरनं आपण जेव्हा चंद्राला बघतो तेव्हा त्याची एकच जी बाजू आहे ती आपल्याला आपल्याकडे असतानाची दिसते, ती आपल्याला गोल फिरताना चंद्र नाही दिसत. ओके, पण चंद्रावरती जर आपण गेलो तर पृथ्वी गोल फिरताना दिसेल आणि पृथ्वी एकाच ठिकाणी स्थिर दिसेल. ओके, म्हणजे पृथ्वीची जे रोटेशन आहे ते आपल्याला दिसेल, पण पृथ्वी कुठे उगवते आणि नंतर कुठे मावळते असं कधीच दिसणार. ठीक आहे. ओके, तर या इथे आपण हा कार्यक्रम जो आहे तो आपण थांबवूया आणि विल टेक लेटर. ओके, या सो या इथे हे जे काही पाहुणे आहेत आपले ते आले आणि त्यांनी आपल्या सगळ्या प्रश्नांची उत्तरं दिली, त्याच्याबद्दल त्यांचे आभार. पण थँक यू ऑल द
की तुम्ही पुढच्या वर्षी लवकर या.
Yes. Next time you should ask the questions, more and more questions, and I would like to encourage you to keep asking questions and try to ask them to us, try to ask them to even teachers and other members that are there in your orbit. Yeah? Okay.
सर, या विद्यार्थ्याचा एक प्रश्न आहे प्लीज.
Sorry, we'll take it later, okay? We need to stop this right now. Okay, thank you. There's next program which will also go on. You can ask me later. Okay, thank you.